Wally the water scientist, back today with another water science experiment. Did you know that everything on Earth is in a different state? And I'm not talking about the different states on a map. The common states in science are solids, liquids and gases. A solid is hard and keeps its shape like a bucket, a book or a car. A liquid is wet and running like paint and milk. And a gas can float and move around like helium in a balloon or the air all around us. Gases can have a smell or be invisible like a smelly fart. There is only one thing that can be in all three states, and that is water. My friend Christy is here to show you.
Hi guys, when we think of water we think of this. It's wet and it's running, and it actually doesn't hold its shape. So right now it's holding the shape of the jug, but if we were to pour it into a cup, it's now holding the shape of the cup. This is water as a liquid. Now if we were to cool this water down to below 0 degrees, something pretty cool would happen. It would actually turn into ice. So if we were to pop this in the freezer or put it outside Santa's house at the North Pole, it would freeze. So I've got some ice here, and we can see it's hard and it's keeping its shape. It's not moving around like the liquid. This is water as a solid. If we were to heat up our liquid water at above 100 degrees, it would actually turn into a gas. We call that gas water vapor. Most of the time we don't see water vapor, but you can see it as steam, so maybe coming out of a kettle or in a hot shower or even coming off a hot drink. So I've made some steam here. Just from boiling the kettle, we've got steam coming off the hot water. So the process of turning water from a liquid to a gas is called evaporation. Now, if you'd like to make your own steam, just be very careful because boiling water is really hot and really dangerous. So make sure you get an adult to do it for you.
That's great, Christy. So here are our three states of water: solid, liquid and gas. If we make liquid really cold, it freezes into a solid or ice. If we heat the ice, it melts back into a liquid. Further heating the liquid turns it into a gas or water vapor. And cooling the water vapor down turns it back into a liquid. Water is pretty amazing stuff. Christy is now going to show you how the temperature of water can make it behave differently.
Okay guys, so I've got 2 bottles of water here. This one has icy cold water in it, and I've put some blue food dye in this one so we can see that it's the cold. And this one has hot water in it, and I've put red food dye in this one so we can see that it's the hot one. So we're actually going to release both of these into a tub of water and we'll see what happens.
What we're seeing is the cold water going to the bottom and the hot water going to the top. This happens because of something called density. Density is how squashed together or thick an object is. Let's compare density and sugar. If you have a lollipop, the sugar is melted together and is really thick, so it is really dense. Fairy floss is also made of sugar, but the sugar is thin and spaced out to make it fluffy. This is not very dense at all. Water can have different densities as well. Water is made up of something called water molecules. These water molecules are so small that just one drop of water is made up of billions of trillions of them. When water is hot, the water molecules bounce floats around and are more spaced apart, like the sugar in the fairy floss, so it's not very dense. When the water is cold, the water molecules don't move much at all, so they are squashed closer together like the sugar in the lollipop. So the cold water is more dense than the hot water.
As you can see from our experiment, if the colder water is going to the bottom and the hot water is going to the top, then water in our rivers, lakes and oceans must be denser towards the bottom and less dense near the top. I wonder what happens when we add ice. It is really cold, so will it go straight to the bottom? Let's try it. It floats. Why is this, Wally?
The water molecules in ice have arranged themselves in a way that is less dense than the hot water at the top, so they float on top instead of sinking. Thanks for tuning in. We hope you enjoyed today's water experiment on the states and densities of water. We hope you all learnt something new. Bye!